Alright, now is the screen visible?
Yes, sir.
Okay.
Yes, sir.
Okay. So what I wanted to say is ki we have uploaded few PDF, all right, and those are nothing but these are well structured handwritten notes of this mineral group. All right, so they are pretty much exam ready. If you are able to produce these in exam, then you will get very good marks, about 80-85% marks out of 100. All right. So like yesterday we finished, or day before yesterday we finished this olivine. So you can go through these handwritten notes, and you can add something if we have missed something. So this is about all. Olivine is nothing but in nesosilicate, isolated tetrahedra. Then there are end members, we discussed them. Then this is about the structure, and some occurrence, and then general properties are also there. Like we didn't discuss hardness and all. This with time, when we will be done with petrology, this will come naturally to you. Now you won't have to remember this hardness. Then you will know some idea that olivine is relatively less harder than garnet quartz, and quartz hardness is 7. So you will be able to predict some of these points. So I didn't cover them. I covered all the important points. Now we discuss about this, whether they are positive, biaxially positive, negative, extinction, and interference color, and all these things, color, and these things. So after class, go through these. Alright, today we will be done with garnet. So after class, go through this PDF which is uploaded on the portal. Alright. So okay. So now I will start today's class. I'll revise it a bit for you what we covered till now. So now we know that these are the minerals which are like important for us, for exam point of view. So we covered olivine. Today we'll cover garnet, aluminosilicate. We'll also go through epidote. Alright, and then we'll complete pyroxene, and if time permit, we'll also do amphibole. These are very important. Alright. So I hope you are comfortable with olivine, and you have revised your this silicate structure. So alright. I hope you have revised these basic physical properties. You are comfortable with this. What is hardness? What is density? What is color? Enhanced specimen. What is streak? Streak is nothing but the color of powdered mineral. At times, the natural color of the mineral, and if we powdered the mineral, they are different. So that is also an identifying property, right? Then we discussed briefly about this fluorescence and phosphorescence. When we put a mineral in a UV light, there is a lamp, UV lamp. Then if we put it there, then it glows. If it glows, then it is fluorescence. If it glows even after removing from the light, then this is phosphorescence. We saw a few examples like fluorite and calcite, sclerolite, all these things. Then we practiced making diagrams of silicate, basic silicate structures. I hope you have like practiced this at your home also. So this is very important. UPSC asked question on this almost every year. And then we covered olivine, right, where its position is there in Bowen reaction series, that it is ultramafic in composition. Then we discussed about silicon is to oxygen ratio, it is 1:4 as it is nesosilicate. Then we studied about various members of this olivine family. These are the members, the triangular diagram, then alteration, we read about alteration. And then we also discussed briefly about spinifex texture. Of its detail we will also study in igneous petrology, which is your next topic. Igneous will begin from tomorrow after geochemistry is completed, right? And then we have covered this all right. So now I think today we'll start with garnet. It is garnet group of mineral. All right, garnet group. All right, so it is a very important mineral. It is also a very like common mineral. If you go to a geological lab, petrology, mineralogy lab, so there we see, in the thin section there are various minerals, and we see them under microscope. So in microscope, this is like in those slides, this is a very common mineral, garnet, and it is also a very fun mineral because it is very easy to identify. So a normal geology student can identify garnet very easily. So this is how this looks in hand specimen. Now if you will bring it from field, if it is a big sample, then see Generally, it looks reddish, deep reddish in color. Even it gives vibes of a gemstone kind of thing. So it is a very deep and a beautiful kind of a mineral, garnet. So this is a general picture, but the color may change depending on its composition. All right, if it is rich in chromium, if it is rich in magnesium, then its color might change. But this is a general depiction. So like, just giving you for an overview, these are the basic names of garnet mineral. All right, this is alamandine, this is pyrope. What we saw just now is it might be either spartine or pyrope. So these are two important, very important minerals. This is andradite. All right, this is grossular. It is also very common mineral. This is ubravorite. So you don't have to remember all these names. Just see that this is how garnet looks. Most common garnets are these two and this grossular. These three. So GAP, grossular, alamandine, pyrope, and then spessartine also. This is also very important. So these four are very important. Always remember this, at least this gap for garnet. All right. So gap means, I hope you got it. Gap means G for grossular, A for alamandine, P for pyrope. So this is how they look in hand specimen. So, and if you see a garnet mineral under microscope, that is in a thin section, then this is how it looks. This is garnet in plain polarized light. So but it looks so distinct, right? If you will zoom थोड़ा सा ध्यान से देखोगे, you will see कि this ये थोड़ा उठा हुआ है. This garnet is a bit raised relative to this. Suppose we call this is E mineral, this is B mineral. B is nothing but garnet. So you can see this is raised one. So this shows that this has relatively high relief. So it is very easy to decipher on see if we get, and see this is also very well formed crystal. You can clearly see this outline. So, and if the best thing is, if we see garnet in cross polar light, all right, in cross polar, what happens is it go extinct. 360-degree rotation पे भी it looks extinct. You won't be able to see garnet. It will look this all dark, black colored. All right. So, okay, can you tell me, if a mineral goes 360-degree extinction, 360-degree extinct under cross polar, what could it be? Is it likely to be an isotropic mineral or an anisotropic mineral? In
Isotropic, sir.
all right, isotropic mineral undergoes 360-degree extinction. So yes, garnet is a common isotropic mineral. So that is why I said it is a fun mineral, because if there is an exam for geology student and they get this garnet and along with some another mineral, then garnet is very fun. You will identify it quickly only. So it is an isotropic mineral. It goes 360-degree extinction. So like this is a favorable in that sense. So let's start this garnet. All right. So garnet is a silicate mineral. Obviously, what kind of silicate it is? It is nesosilicate. And this garnet has even as mentioned in our text, in our civilizational text. Like you must have read in this Indus Valley civilization, we used to have import-export of this gemstone. All right, with Mesopotamians. So this was one of the mineral garnet beads. The women used to wear the beads. So sometimes those beads include this garnet mineral. So we as in civilization are aware of this garnet from like very very long time, and this is also used as an abrasive. This is a common point. You can like most of the ultramafic or the rocks, most of the mineral, you can write this point in exam in uses. They are used as an abrasive because it is decently hard enough. All right. Then, like I just discussed, there are various different species. There are various different minerals in garnet group of minerals. The name of which is this pyrope, alamandine, spartine, grossular, uvarovite, and andradite. So don't worry, don't get tense by that how you will remember all these names. I'll help you to simplify these and remember them. Alright. So actually there are two solid solution series for garnet. All right. So you can you can write this in your note. The first point about garnet is it is nesosilicate. You can draw the nesosilicate structure, single silicon tetrahedron. All right. So ये इसका basic structure हो गया. First point. Second point is it is isotropic. If you know what that a mineral is isotropic, you can automatically write couple of points, right? One of my friend, he mentioned that it will go 360 degree extinct in cross polar. All right, most of the isotropic mineral, these have very equivalent and well formed euhedral kind of crystal shape. All right, crystal habit. And the third point you can write is all isotropic mineral, they have which kind of crystal system?
Isometric.
Yes, isometric, or we also call it cubic. So just by knowing this one property, you can derive these 3-4 points in 3-4 sub bullet points in exam. All right. Then the fourth most important thing is classification. All right. So this garnet is classified into basically two series. Just remember these two names. One is parallelspite, another one is ugrandite. Right? So just now read them. Pyrope, elemendine, spacertine. All right. This parallelspite is nothing, इन्हीं का combination है. All right. P for pyrope, है ना, PYR for pyrope, AL for elemendine, and this S for spacertine. All right, spacertine. See the pronunciation on the Google ones. All right. So pyrope, elemendine, spacertine. Just revise them multiple times. You will it will be remembered. Then this is ugrandite series. In this U for uvarovite. This G for grossularite, or we also call it grossular. Alright, and then this andrite is nothing but this. Ugrandite mein andrite is nothing but andrite. So these are the 6 minerals in garnet group. Alright. The most important in this you should always remember is this GAP, because this will come time and again in metamorphic petrology. When we will study about we will study about facies and all, then this grossular, elemendine and this pyrope, this will keep coming on, and you will be writing this in exam also. Alright, so this is it. Now you can also zoom a little bit on it. So firstly, the third point, before classification, you should also remember the general chemical formula. So we know that it is an nesosilicate. Nesosilicate is silicon is to oxygen ratio. Alright, 1:3, and then X3, Y2. Well, I'll cover it in the next slide. So you just remember firstly this name. Alright, this classification. So these are two kind of garnet. One is pyrrolite, second is ugrandite. Alright, and write somewhere this gap. Always remember them. At least remember these 3 names. But it is best if you remember all the 6 names. So you can see pyrope is nothing but it is magnesium rich garnet. Elemendine is iron rich. So these two have dark color also. Iron magnesium provides dark color to the mineral. Then spacertine is manganese rich, and this ugrandite series is calcium rich. Alright, so you can see these this pyrope and spacertine, these are all dark colored mineral because of iron, magnesium and manganese. Alright, this savorite, this has chromium in it, so it chromium impart it as a green color. So this is like basic thing you can remember. Then these are some of the physical properties. So now normally a lab going student will say that garnet is red or brown or maybe blackish in color, very dark. But based on property, it can be green, it can be yellow, all right. It can have another color also. But 90% of time which we get in our lab and in nature, it will be reddish in color, all right. The stick is colorless, all right. And then you just saw that the lusher, sometimes it is bright, and then in some of the mineral it is like dull kind of lusher, no? The sparkness in it. Then there are no cleavages, like we mentioned that in nesosilicate, most of the nesosilicate mineral don't have good cleavages, they have poor cleavages, all right. They will have some uneven fractures, all right. So you can see some random uneven, they don't sometimes they don't even have fractures, it has conchoidal kind of fractures, and it has some random fractures. You can see this is a fracture, this is a fracture, something like that. So they have uneven or conchoidal fractures. We discussed its hardness is about 6.5 to 7. It is as hard as quartz, almost like quartz, all right. And since it is isotropic mineral which crystallize in isometric crystal system, it is bound to have good euhedral kind of crystal habit. So I think this is something which you can decipher of your own. You don't have to mug a lot of it, and with time when we will read petrology, you will be very comfortable with physical properties, right? So these are the notes, you will get them on the PDF also. So like this is it. This is the formula, general formula, we just saw it, all right. You can write it in your copy, A3B2. Actually just see, SiO4 has -4 charge, and this is a 3 number, so it has total -12 charge. So we need cations which can neutralize this 12 charge, all right. So in garnet we have two cations. First we call as divalent cation, all right. This here A is divalent cation and B is trivalent cation. Trivalent means 3 valency, divalent means 2 valency. So normally the divalent cations include iron and magnesium, as we saw, alright, dark colored mineral, and manganese also, and calcium is also +2. And if there is trivalent cation present in garnet, they will mostly be aluminum. Sometimes chromium also is there, sometimes +3 iron is also there. So just remember this if possible. If you are able to remember this, then it will be good, and if you don't remember in exam, then also it is not much of the harm, but it is good to remember this at least, and you can easily write what will be trivalent or what will be the divalent. And you can also write this name. You know which cations are +2, which are +3, all right. Crystal system is isometric, and we have divided them into two categories: pyrrolspite and ugandite, all right. And pyrrolspite include pyro, alumandine, spessartine again, and these are grossular, andrite and uvaroite, all right. Then the next sixth aspect is its occurrence, like where you will find garnet. Garnet is a mineral, so it will be formed in association with some rocks, all right, in which whether they are found in sedimentary, in metamorphic or igneous rocks. So you will see that you are writing this occurrence subheading in almost all the minerals. So it just means you will have to write on these dimensions, whether it is found in igneous rocks, metamorphic or sedimentary. In some time you will be knowing names of few of the metamorphic rocks, so you will be able to predict in which rocks this garnet will be formed. So I will not go in detail. This is for this, you will understand after completing petrology, all right. So this is it. Then see some important characteristic property of garnet. So if sometimes they ask question in this language only, write a short note on identifying properties of garnet. Like if somebody is given you a mineral, how will you conclude that it is garnet? So you know that since garnet is isometric, it will have 360-degree extinction under cross polar, all right. and if you are able to write this, it is isometric system. In exam you can always write in isometric system, it will have all its edges equal, the angle between the edges is 90 degree, and all are equal. So this is additional information you can borrow from crystallography, right? Then the second thing is it has very high relief, which we saw here, है ना? You can see relatively it has a high relief with respect to this mineral, even with respect to this mineral, right? So it is an high relief, hard kind of a mineral. Right, it has euhedral habit, and then you can write about the color. So like these are the basic properties of garnet. So I think this will be sufficient for the examination. So what is most important is to remember this name, these two series, pyrolusite, ugandite, and remember that it is isometric, then isotropic mineral, and then you will be able to write all these things. So right, this is all about garnet group of minerals, and I think we have uploaded this slide also, and the same information is there. All right, so if even you don't have the notes, you can just get print out of these notes, revise them multiple times. All right, and then make your own notes. That will be best. Like these are of, I think, 5 pages of notes. You can make it in just a single leaf, or maybe in 2 leaf. So that would be best, right? Okay, the next topic I want to complete cover is this aluminosilicate. All right. Actually, why I am covering this here, I think you must have covered this in topic of polymorphism. So actually UPSC hasn't asked this directly, write a short note on aluminosilicate or something like that, but it can ask. It is an important mineral group. This is like widely formed with metamorphic rocks. All right, and this is the question which UPSC has asked hundreds of times about polymorphism. So if you are writing about polymorphism, you will define definition and all these things, and you will have to give few examples. So this aluminosilicate is one of the best examples of polymorphism, and there is of course example of quartz, which we will do in the next class. So whatever you learn here, you fit that in the question of polymorphism also, right? So this is it. So if you are writing about aluminosilicate, you will start with that it is a nesosilicate. Alright, nesosilicate, you know the structure, draw the structure, write about it, that it is a isolated tetrahedron, right, and all these things. Then you say that aluminosilicate, they exhibit polymorphism. Define polymorphism. You know polymorphism means, poly means multiple, many. In morphism in English dictionary, it will mean shape, the morphology, how does it look like. So these are the minerals which have same formula, that is this, but they have different structure. The change in structure might be induced due to change in temperature and pressure condition. So then the second thing about this nesosilicate is about polymorphism. So you will say that there are three mineral with this aluminosilicate formula, but different structure. All right, different structure, and they are this AKS is andalusite, kyanite, and the third one is sillimanite. This is an often repeated question on aluminosilicate or in polymorphism. So you must remember these three names: andalusite, kyanite, and sillimanite. Right. So you have to draw this diagram also. If you will draw a pressure temperature plot for aluminosilicate, you will find that Alright, this is temperature field, this is pressure field. So you will find that in relatively low pressure zone, you will find Andalusite. Alright, in very high pressure zone, we get kyanite, and in the higher temperature range, we get sillimanite. Alright. So remember this triple point. This is a point and which naturally there is probability of finding all the three polymorph of aluminum silicate. Alright. So this triple point is nothing but this is 4 kilobar pressure around 500 degrees Celsius. So just remember this. If you are able to draw this diagram in any polymorphism question, it will give a good impression. Alright. Alright, this, so, and just remember this triple point, this one. So now we will have to discuss, we will have to brainstorm few of the properties of aluminum silicate. So like I want to ask you one thing, like the first thing we will talk about aluminum silicate is coordination number. Alright, so can any one of you define what is the coordination number? Attempt defining this coordination number.
Number of atoms surrounding a central atom.
Yes, or you can also say that number of
bonds with a central atom.
Yes, number of cations. Number of anions surrounding a cation.
Surrounding a cation.
Yes, right. So generally we define this coordination number vis-a-vis a cation. Alright. So it is about how many anions are surrounding the cation. It is simple thing. So what happens is, like we were discussing about this. This is A, K, and in this pressure temperature region we get kyanite. Here we get this andalusite, and here we get sillimanite, right? So we have learned that what are the factor on which coordination number depends, right? We have read in Pauling's rule. What we have read? We have read that this Radish ratio, R plus upon R minus, this ratio governs coordination number, right? If R plus by R minus is 1, then we get coordination number of 12. If it is between 0.73 to 1, then we get coordination number of 8. We have seen this in nature and we have also derived it. Then if it is 0.42 to 0.73, then it is 6, something like this. So we know that Radish ratio, the relative radius of R plus, positive cation, and negative anion, it governs this coordination number. But in nature there is a third important factor, alright, which governs coordination number, and that is pressure. You just visualize, suppose this is a cation and there are various anions. Naturally it will have like 4 anions around a cation, alright. What happens is, if there are more cation, there is repulsion. If I put in another anion here, so there will be repulsion between these anions, there will be repulsion between these anions. So naturally they won't come in here, alright. It will have this natural coordination number. But just visualize a condition when the pressure in this area has increased. You are forcing more and more anion to occupy the space. So if pressure increases, coordination number of a cation might also increase. Alright, because it is common sense only. Under pressure there will be less space and more anions will have to occupy the space. So this is the third thing. So you can see, as the pressure will increase, if suppose we talk about kyanite, suppose we talk about andalusite. So andalusite normally has 4 coordination number. Sometimes it also shows 6 coordination number, right? But when we encounter kyanite mineral, we see that the coordination number of kyanite is 6. From 5 of andalusite, coordination number becomes 6. So it is due to the condition in which it is formed. It is formed in high pressure condition. Similarly, in sillimanite, due to more temperature, the coordination number is low. So in sillimanite, the most common coordination number of the cations is 4. Here it is 4, here it is 5, the most common, and here it is 6. So this is one of the major difference between these three polymorphs, right? Then the another difference in between these AKS is the crystal system. All right. So this andalusite and sillimanite, they crystallize in orthorhombic crystal system, and kyanite, it crystallizes in triclinic crystal system. All right. Similarly, the third difference is sillimanite has one cleavages, as well as andalusite and kyanite, they have two sets of cleavages. Alright, and also there is a difference in the angle between the cleavage, the two sets of cleavages of andalusite and kyanite. With this we'll see in the next stage. See, this is a diagram also. You can see, although they have same chemical formula, all three of them, but their look is very different, right? In this temperature pressure field, we get andalusite, here we get kyanite, and here we get sillimanite at very higher temperature and maybe higher pressure also, right? So this is in high pressure polymorph, this is a low pressure polymorph. Alright, this is in higher temperature polymorph, sillimanite. So they look different because they have different crystal system, they have different sets of cleavages and some other differences, which we can summarize using this table. So this UPSC has asked this question once, maybe in IFS, that distinguish between the polymorphs of aluminosilicate. All right. So if there is this similar question, distinguish between polymorphs of aluminosilicate, then you can, as an introduction, you can say that aluminosilicate is a nesosilicate, and then you can draw the structure of nesosilicate and something like this. But your main content, which will fetch you mark, will come from this, right? So firstly tell there are three polymorphs of aluminosilicate. Draw this diagram, pressure temperature plot, and depict the triple point, 4 kilobar pressure and 500 degrees Celsius, and then come to this important properties. So first property we already discussed is coordination number. So coordination number of coordination number of this kyanite is maximum, then its coordination number is andalusite is 5 and of sillimanite it's 4, right? So this is one of the difference. Second difference is in their crystal system. So this andalusite and sillimanite has orthorhombic crystal system. So if you are able to remember this, then you will be able to write alpha, beta, gamma and ABC. So these are extra fodder point, right? The filler point in your answer. So this is something which you will have to remember. Then there is also a distinction between their extinction, right? So kyanite, see, since kyanite also has a different crystal system, it also has a different extinction. So these both have parallel extinction because alright, and this is also you need to remember. And then this is the third point which we need to remember is that sillimanite has only one set of cleavages and andalusite and kyanite has two sets of cleavages, right? And the angle between the two sets of cleavage in andalusite is 90 degrees. So it will look something like this. This is one set of cleavage, this is second set of cleavage. Angle is around 90 degrees Celsius, 90 degree, right? And in kyanite they have a about 79 degree angle, right? So this is an example, and all the three are biaxial minerals. So I think you don't have to mug it up. If you know that if they crystallize in this orthorhombic or triclinic, then they will be biaxial, right? We know that in this three crystal system, orthorhombic, microclinic, triclinic, the minerals are biaxial, right? This is a thumb rule. And in hexagonal and tetragonal, the minerals are uniaxial. And isotropic mineral have isometric crystal system, right? So these I think this is not so difficult. You can if you remember the formula, if you remember that this shows polymorphism, and if you remember this diagram, AKS, and you are able to draw AKS, then it is all easy. You easily predict with pressure, coordination number will increase. Then you have to mug up about the extinction, all right, and this crystal system thing, right, and then you can also include information about cleavages and this biaxial uniaxial thing, right. So this is it for aluminum silicate, right. And then you will be having some fodder from polymorphism topic also, and also from the topic of mechanism of polymorphism, how polymorphism occurs, which I think Lawrence sir will be covering in the in one of the extra classes someday, or maybe I will cover in the next class. So you can have more fodder point on aluminum silicate from those dimensions, right. Okay, so the one more or maybe two more mineral I want to mention in nesosilicate is the one is staurolite, right. It is a very common metamorphic mineral. It is formed in metamorphic rocks. But why I wanted you to know that you must have read about twinning, right? And you must have read about penetration twinning. So this is a very fine example of penetration twinning. This mineral staurolite shows penetration twinning. So, if you have not added this in your note, then add this in your twinning notes. So this is also a nesosilicate mineral, right? And then one more important mineral which we should know is zircon. Alright, so this is how zircon looks like, right, this, but this looks pretty much like garnet also, and you can have a feel that it is also very tough, very hard kind of a mineral. So why I am covering this zircon here is because it is very, very important in sedimentology, in a topic we called as heavy minerals. Alright, they have some very important use in geology. So it's good that you know the name of this mineral from mineralogy itself. And the second thing is, which we'll discover in a few minutes, right. So about zircon, the first thing about zircon is its formula. It is nothing but it is ZrSiO4. Zirconium. Zr is zirconium. It is a heavy element. So zirconium silicate. Alright, so this also have a nesosilicate. If sometimes UPSC asks you to write something about zircon, then you will have some fodder point. It is a nesosilicate, alright, in its structure. Then you can write about nesosilicate, you can draw the diagram of nesosilicate, structural diagram of nesosilicate. The second most important thing about it is a very hard mineral. Alright, so what is very important about it, is this zircon is very seldom, is very rare in thin sections, because it is so hard that when we bring a rock which has zircon and we convert it into, see, it is written, it is so hard that it gets plugged out during grinding of the section. Like when you bring this rock which has zircon to the lab and we convert that rock in thin slide. So when we convert the rock, that mineral in thin section, we grind it on a machine. So during grinding, it is so hard that it won't get grounded, but it will get plugged out as a whole mineral itself. So we don't find it very easily in thin section. So it is like a very, sometimes they may ask you in sub part of a question that why zircon is not found very easily in thin section. So the reason is its hardness. Due to its hardness, it's get plugged out. Alright, this is one of the thing. And one more typical identifying character of this zircon is its pleochroism. Alright, so it has this pleochroic halo. You know what is halo? Halo is like we have seen in our various god, like this is Gautam Buddha, this is an halo. Alright, something pious kind of a thing, something emanating from behind. So this is a thin, if you will get a zircon in thin section somehow, it might show this halo, some kind, something like this. So it's one of its identifying properties. So alright, so this is one of the typical properties. And then another most important thing is this zirconium element is almost similar and compatible in size, radius size, than uranium and thorium. So at times what happens that in this zirconium, a lot of time zircon is replaced by uranium and thorium, right, in its crystal structure. So if suppose we have got a rock which has we have got a rock and which has many mineral, right, and one of the mineral is zircon, right, this is zircon, these are some other mineral, right, so something like this. So if we have zircon, then there is very good chance that the zirconium in it would have been replaced by uranium and thorium, right, and uranium and thorium are radioactive elements, and radioactivity helps us in what, in dating, in knowing the age of the rock. So if we find zircon in a rock, alright, then it is easy for us to date the rock. We can know the age of the rock and other things, the geological history. So that is a significance of zircon, that it helps us in dating of the rock in which it is formed, right. And some other property of zircon, like optical properties, since it is hard mineral, so it is bound to have a high relief. It has higher order interference color, second and third order interference color in Michel-Levy chart, right. So this is about zircon. So I think you understand why we did zircon. The two typicality of a zircon is, one is this pleochroic halo. You can draw in exam like this. The halo diagram you can draw like this. If this is a mineral, then this is the halo, right? This is zircon. So we get a halo kind of thing. And the third thing is, it is very rare in thin section because it gets plucked out during the process of grinding when we convert it into thin section. And third thing, most important thing is, it helps us in the dating of the rock, right. So I think we have completed our nesosilicate part, right. So in nesosilicate we covered olivine, we covered garnet, and then we went through aluminosilicate, AKS. Then we read something about zircon. We also had a mention of staurolite, right. So like these are two very important. UPSC will directly ask these two questions. This is included in polymorphism. This is also highly important, and sometimes they may ask this also, and this will be important in sedimentology, right. So I think we are done with nesosilicate. So if you have any doubt, you can ask. Otherwise I will start with the sorosilicate part.
Sir, zircon is uniaxial.
Zircon, I will have to see its crystal system. I don't have. Wait, I'll see whether it is in your notes or not. I don't remember the crystal system.
Tetragonal is it? Or?
Okay, wait, I'll Google it for you. I don't remember it. It is not in my note. It is tetragonal, right?
So will be uniaxial.
Yes, it will be uniaxial. So you can add this information in your notes, right? Or this is also there in the PDF, so you will get it there. So I just covered important part. This you can add this small information from some text also, right? So we can start with sorosilicate, right? So this our second silicate is sorosilicate. So sorosilicate is also known as pyrosilicate. Actually this was an early classification. These days we don't officially call it pyrosilicate, but maybe in paper the professor is of old school of geology and he gives you write a short note on pyrosilicate, and you will feel that अरे तो मैंने पढ़ा ही नहीं है, but it is nothing but it is sorosilicate. So just remember this. We have already covered that it has two silicate tetrahedron linked together, right? So you also are aware of its structure, silicate structure, right? So you can draw this structure. We covered this in last class also, right? Something so simple. So it's the silicon is to oxygen ratio is 1 is to 3.5, right? So this will be the anion part, and there will also be cation. So this is borosilicate. All right. So actually, till now UPSC hasn't. I haven't come across a question when they have even asked us to write a short note on borosilicate. But they can definitely ask us. They do ask us write a short note on silicate structure. Then we will have to cover borosilicate, right? But they haven't till now asked any specific mineral which have this borosilicate structure. So like based on other exam, based on GSI and GATE, I thought that these are the 4 minerals which are important, which UPSC might ask someday. So the 4 important mineral which have this borosilicate structure is, you should remember epidote for sure. It is a very very important mineral in metamorphic petrology. Like then there is lawsonite. You should have this mentioned in your notes. Third one is elenite. The fourth one is pumpelite. Actually, you won't find this elenite in most of the book or even in important question. But I covered this because few days ago there was a news about this mineral, related to China, the mining in China, and the important part of this mineral is it is rich in rare earth elements. Like I am sure you have covered rare earth element yesterday in geochemistry, and rare earth elements are actually very important for electronics industry, for this battery, electronics battery, and future automobile industry, and for other purpose also. They are used in almost all the industry. And China has a kind of monopoly on this rare earth element. So this elenite was in news like last year due to some reason. So I included this in the notes. So since they have a borosilicate structure, so I am covering them here. So they won't ask you directly about elenite, but if you yourself mention it in under borosilicate, it will definitely give you some additional marks, right? So I'll start with this elenite only. So you don't have to go remember all the optical properties or physical properties of elenite, because they will never ask. Even I have never seen this elenite in a thin section, but you can just mention that elenite is something which is rich in rare earth element, right? So actually, see, just have a look at this formula, right? This is silicate. It also has a space for hydroxide ion in its crystal system, alright. Then it has aluminium, iron, and in +2 divalent cation, sometimes rare earth element, right? They occupy the spaces. So this is why it is important. You don't have to remember this formula, but I am just writing it to give you a view that where these rare earth elements are present in this elenite, right? So there are actually 2 kinds of elenite. Actually you must be knowing that rare earth element, a lot of rare earth element are radioactive, right? A lot of rare earth element are radioactive. And what is the property of radioactive elements? They decay with time. So sometimes what happens is, due to this radioactive decaying of this rare earth elements which are present in the lattice of this elenite, few of the elenite, they convert from crystalline to amorphous. They lose their crystal structure because of this decay, right? So we call them as metamict. They are the metamict class of elenite, right? METAMICT. And there is another class which is pyrogamic. Alright, they have the property, if we heat them above 95 degrees Celsius, they develop an incandescent light. So this is nothing. I have just given you some information. Just remember that elenite is rich in rare earth element, and a lot of rare earth elements are radioactive. Due to this radioactive elements, they sometimes loses their crystalline structure, and they become amorphous. Such kind of elenite minerals are metamict and Then there is another class that is pyrogamic, and this is one of the property. So even if you remember that allanite has rare earth element, that will be sufficient if you mention this one line in exam under sorosilicate, right? The second important mineral is this lawsonite. Alright, so lawsonite is very important in zeolite phases. This is a very important. This is an important topic in metamorphic petrology. So there you will come across this lawsonite, name of this lawsonite. So just remember this name. If when you read it in metamorphic petrology, it should click you that it is a sorosilicate. I have read about it. Simple. And then similar is with this pampelite mineral, right? So this is also a metamorphic mineral. So just remember these three names. What? Lawsonite. Even if you forget them in sorosilicate, that is not an issue. Second is allanite, and third is pampelite. This might look a bit difficult. याद कैसे होगा? But you will remember, you will hear this name so many times in metamorphic कि ये भाई common सा हो जाएगा. So that won't be an issue. All right. And this is also a part of zeolite phases. You can just mention it. इसको बहुत डिटेल में करेंगे इन मेटामॉर्फिक, राइट. एलेनाइड इज रेयर अर्थ एलिमेंट. दिस इतना याद कर लो, ठीक है. द मोस्ट इंपॉर्टेंट मिनरल फ्रॉम दिस सोरोसिलिकेट इज एपिडोट. दिस यू शुड रिमेंबर. It should be in your main notes for sorosilicate. So this is epidote group of mineral. Epidote itself is a mineral in this epidote group of mineral, right? It is an important mineral. And then there are two other mineral. One is zoisite and one is clinozoisite. राइट. सो ये तो याद रखना है आपको. उनको एपिडोट ग्रुप ऑफ मिनरल में तीन मिनरल हैं, EZC और EZC वो ना EZC. सो जस्ट रिमेंबर दिस एपिडोट. एंड so sometimes UPSC hasn't asked till now, but just be prepared कि कभी पूछ लिया ऑन सोरोसिलिकेट एपिडोट पे ही. so you should have some fodder point ना. इतना प्रिपेयर करने के बाद there is no point कि we leave our copy blank. so this is how a normal epidote looks like, right? In a hand specimen, if you visit any geological museum, you might find this. This is something like this. So the most important thing, now there might be a question about epidote group of mineral. So you will say that these are the three: epidote itself, clinozoisite, and zoisite. These are part of epidote group of mineral. So इनमें सबसे बड़ा difference is their chemical composition. Epidote is rich in iron, and clinozoisite and zoisite, these are not rich in these are iron free variety, right? so यही पैरा पॉइंट हो गया. सबसे इम्पोर्टेंट इतना याद कर लो, ये इसमें आयरन है एंड इसमें आयरन नहीं है, दोनों में, राइट. देन द सेकेंड थिंग इज you can see this extinction, right? so in this clinozoisite and zoisite, these are pretty same na. See, this clino term come from this monoclinic, right? Zoisite is nothing but, remember this is nothing but this is O for O is here, and it is orthorhombic crystal structure. It is crystallized in orthorhombic crystal structure, and this is not orthorhombic. This is clinozoisite. This is monoclinic, and this is also monoclinic. If these are monoclinic, you can decipher that they will have two apteric axis, right? They will be biaxial from our thumb rule. OMT crystal system are biaxial, right? Then the second important thing is, when you will see it in under plane polarized, right, epidote will show pleochroism, right? When you will see epidote in section in petrological microscope, and you will rotate the stage, right, then there will be change in color. So epidote will have pleochroism, but clinozoisite and zoisite don't have pleochroism. They won't change the color when you rotate the stage under plane polarized light, right? This epidote is also is relatively hard, so it has relatively higher relief, right? These two don't have higher relief, right? It also shows higher order interference color, what apidot. So it is very easy. You just have to remember one thing, that which crystal system monoclinic this apidot has. It is monoclinic, and then this you can remember this. It shows pleuroclasm. It has high relief. It has high order birefringence. Okay, so it has high order interference color, and it has high birefringence, right? Then how will you differentiate between, इनमें तो सेम ही सेम प्रॉपर्टी आ रही है ना. You won't be able to see crystal system under microscope, but pleochroism they are not showing pleochroism. They even don't have high relief. Birefringence भी उनका low है, but you can differentiate them based on extinction, right? So zooxide has parallel extinction, right, and this clinozoicide has inclined extinction. So this is a single point जिसमें तुम इन दोनों को clinozoicide और zooxide को we can differentiate them, right? And obviously this is chemical composition difference. So these are the 5 points which if you remember it will give you good marks in apidot, right? So now I think we are done with this sorosilicate. In sorosilicate you have to remember what? Apidot, group of mineral. Remember all the three names: EGC, apidot, zooxide and clinozoicide, and remember these three names, right? These are important metamorphic mineral, right? Elenite you can remember because it was in news last year, mainly because of rare earth elements, and just remember this much, right? So now I think we can proceed to the most important silicate group of mineral which comes under chain, right, or iosilicate. Sometimes they will not write chain silicate. If they write chain, then even it is easy, single chain and double chain. But sometimes they write iosilicate and you get confused between iso, soro or ino, something like that. So just have this in your notes, right? So we know that chain silicates, there are two kinds of chain structure. One is single chain structure. We read it in the last class. One is double chain, right? The mineral which have single chain structure is the most famous, pyroxene, and the mineral which is double chain structure is also a very famous mineral. We call it amphibole group of minerals, right? So I am pretty sure you all can draw the silicate structure of single chain and double chain. So just draw it in your copy, how you will draw single chain structure and how you will draw double chain structure. At least draw single chain. We practiced it yesterday. Draw it in your copy right now. Like we said that you can have the 6 dots. Right? So this is something like this. This is what? Single chain. Right? और इसी के नीचे if you join them with another single chain, you will get double chain structure. This is like very very important, and I think this will not come in video. यहाँ पे शायद वो कैमरा आता है, but you can have it. मैं ऊपर बना देता हूँ. Right? I think you got it. What I want. Just practice it and make it similar. Have you drawn this both single chain and double chain in your notes?
Yes, sir.
Right. Now do practice them. Right. Like this is one of the most common question in exam. Right. There are few topics which you should have. These should be in your tip. One is silicate structure. In every mains UPSC ask, or in forest services they will always ask silicate structure in one form or the other. या तो बड़ा क्वेश्चन पूछ लेंगे, इसी पे लिख दो नोट ऑन सिलिकेट स्ट्रक्चर, और स्पेसिफिक पूछ लेंगे, आयनो पे लिख दो, सोरो पे लिख दो ना, नीजो सिलिकेट, और मे बी this quartz wala, last wala, tectosilicate. All right. Then the one question is also very common is about landslide. You know, this comes mainly from environmental geology और समटाइम इंजीनियरिंग जियोलॉजी में भी पूछते हैं. तो समटाइम ऐसा भी होता है कि दोनों पेपर में लिखना पड़ेगा लैंडस्लाइड पे, है ना. दे विल आस्क लैंडस्लाइड इन फ्रॉम एनवायरमेंटल geology syllabus, and in paper 2 they will ask you from in paper 1 they will ask from engineering geology, in paper 2 they will ask from environment geology. So mass wasting पे ना you might be writing 2 answer. Actually I have written 2 answer on meteoroid. I don't know, it was I think 2018 forest services or civil services. So there the first question in paper 1 was about meteorite, and there was the same question, same without any change in wording in paper 2 also. So you know this is very common. So one is silicate structure, landslide, about meteorites, this is also very common, and there are some other which I'll like tell you whenever they come to my mind. So these you should be very thorough with these 4-5 topics. These are filler questions in exam, right? So now let's start with this chain silicate. Let me see how much time do we have. We do have still some time, right? So see, so right, so chain silicate, there are 2 kinds of chain, single chain, double chain. Double chain ka example in mineral is amphibole. In single chain we have pyroxene, right? We know that in chain, tell me what is the silicon is to oxygen ratio in single chain and what is silicon is to oxygen ratio in double chain. The one who will tell me both right, he will get a dairy milk.
1:3, 4:11.
Oh, perfect. 4:11. So your 1 dairy milk is due, right? So this is it. So first we will start with chain silicate, single chain silicate. So we know SiO3, right? Si2O6 or 1:3 and XY. This is the general formula. Just remember it. Maybe you might find it difficult to remember the formula of amphibole, right? You might also find it difficult to remember the formula of allanite, right? But you know, somebody was asking me ki, sir, like so many people are preparing for geology from the same book, how we will differentiate. So you know, I know it is not possible that you mug up all the formulas. You cannot mug up this lawsonite formula. Somebody can, but mostly it is difficult to mug it up. So I'll tell you, there are few formulas which are very simple, and if you are writing the formula also along with the name of the mineral, he will definitely give you at least half or 1 marks more than the other people. So till now we read about olivine, right? Yesterday we read about olivine. You should remember the formula of olivine because it is not that difficult. What was the formula of olivine? See, you should, this is the classification of olivine, and these are very simple. Mg2SiO4, 1:4 nesosilicate, and when there is iron magnesium series, फेयलाइट फॉस्फेराइट सीरीज. सो लिख लो इसको. तो भाई ओलिविन का फॉर्मूला एटलीस्ट ये दो नाम, फेयलाइट फॉस्फेराइट, एंड इफ यू आर राइटिंग अबाउट फेयलाइट जस्ट राइट छोटा सा दिस फॉर्मूला. if you are writing phosphorite then just write this Mg2SiO4. so at least remember olivine का फॉर्मूला, नाम ये तो याद करना ही है, पूरा ट्राइंगुलर डायग्राम है ना. दिस विल गिव यू एन एज. क्लास करने का, अच्छी बुक से पढ़ने का यही एडवांटेज है. बांगर बांगर पढ़ के यू वोंट बी प्रोड्यूसिंग दीज डायग्राम्स और दिस कंटेंट इन एग्जाम, राइट. देन अब इसमें भी कुछ नहीं है. इफ़ यू रिमेंबर दिस फॉर्मूला, सी इफ़ यू रिमेंबर दिस फॉर्मूला, आपको सारा लिख दोगे. आपको पता है तीन जो एजेस हैं, वन इज कैल्शियम, 100% कैल्शियम, 100% मैग्नीशियम, 100% आयरन. बीच में बस कैल्शियम आयरन ही तो लगाना है, दोनों 50-50 हो गए. ये बोथ 50-50 इज मैग्नीशियम एंड कैल्शियम. सो इट इज़ वेरी इजी. रिमेंबर एटलीस्ट वन फॉर्मूला. ओलिविन याद रखना है, राइट. सिमिलरली गार्नेट भी 99% लोगों को याद नहीं होता है फॉर्मूला, बट कोई डिफिकल्ट नहीं है ना. अगर गार्नेट याद कर लेते हो, गैप याद कर लो, 3 इंपॉर्टेंट मिनरल, और ये याद कर लो पायरोक्साइड एंड यूरानाइट, तो ये सारी चीज़ अपने आप निकल आएंगी इफ़ यू हैव रिवाइज योर नोट 4-5 टाइम्स, राइट, इन एग्जाम. सो इसका हम याद कर सकते हो, बट ओलिविन तो मस्ट है, ठीक है. ओलिविन इज मस्ट. गार्नेट को भी सेकंड प्रायोरिटी पे रख लो. तो ओलिविन याद रखना ही है. देन उसके बाद क्या याद रखना है, एंडेलोसाइड कायनाइट का तो इतना तो याद रखना ही, Al2SiO4. दिस इज द ओनली फॉर्मूला. ऑल द 3 हैव द सेम फॉर्मूला. एंड रिमेंबर AKS, रिमेंबर दिस डायग्राम, रिमेंबर द ट्रिपल पॉइंट. फैक्ट पॉइंट ऑफ व्यू से कंसेप्चुअल चीज़ तो यू विल बी राइटिंग इन एग्जाम, बट फैक्ट के हिसाब से रिमेंबर दिस, ठीक है. देन zircon is like ZrSiO4, you will remember it, right? In sorosilicate, I am not asking you to remember the formula, general formula of epidote, इसलिए मैंने कवर भी नहीं किया ना. दिस इज द जनरल फॉर्मूला एंड यू नो इट इज कॉम्प्लेक्स, so don't remember it, but just remember at least in epidote group of minerals there are these three important mineral and whatever we discussed about their properties, how we will distinct them. One is iron free, the two are iron free, one is rich in iron. So अभी तक फॉर्मूला याद करने का कितना बोला है? ओलिविन याद रखना है एंड एल्यूमिनस सिलिकेट याद रखना है. गार्नेट को भी सेकंड प्रायोरिटी रख लो इफ यू कैन रिमेंबर इट. उसके बाद दिस इज समथिंग जो दे आस्क एवरी ईयर, तो इसमें तो यू नीड टू रिमेंबर द फॉर्मूला ओलिविन के, लाइक पायरोक्सिन के, राइट. एमसीक्यूएल का भले स्किप कर दो. एंड देन उसके बाद दो और मिनरल लास्ट में आएंगे, वन इज क्वार्ट्ज, अनदर वन इज फेल्सपार. सो इसके जरूर फॉर्मूला याद कर लेना. ओलिविन के याद रख लो एंड रिमेंबर द फॉर्मूला ऑफ फेल्सपार, राइट. दीज आर टू मोस्ट इंपॉर्टेंट, इनके फॉर्मूलेज भी याद करके रखना. उसके बाद और एक थर्ड हो गया पायरोक्सिन. ये तीन चीज के फॉर्मूले भी याद रख के रखना. उसके बाद अगर यार एम्फीबोल का इफ यू आर एबल टू रिमेंबर इट, गार्नेट का फॉर्मूला इफ यू आर एबल टू रिमेंबर इट, और क्ले का अप्रॉक्सीमेट जो वो होगा वो इफ तीन, देन इट विल बी गुड. बट ये तीन तो याद होनी ही चाहिए, है ना. इट विल गिव यू 1 मार्क एक्स्ट्रा इन एवरी क्वेश्चन, यू विल राइट द फॉर्मूला. तो ये सब वैल्यू एडिशन है ना. तो इसको बस ध्यान रखो. डोंट गेट ओवरवेल्म्ड बाय सो मेनी नेम एंड सो मेनी फॉर्मूला, बट रिमेंबर आई एम जस्ट पिन पॉइंटिंग फॉर यू कि क्या क्या याद करना है, राइट. सो वील स्टार्ट विद दिस pyroxene. So again this is the general formula of pyroxene, XyN Si2O4, right. And this is the structure, single silicate structure, right, the basic structure. उसके बाद we have this important, very very important classification of pyroxene. मतलब how many types of pyroxene are there. So we'll draw this very important triangular diagram, right. So you know, again I am just revising it for you कि this triangle have three edges, magnesium, iron and calcium, right. And you know how to study them. In this line there is no iron, in this line there is no magnesium but only 100% iron, here 100% calcium, between में there is a mix of both, right. This is how we read it. So two most important kind of pyroxene is orthopyroxene, which जिसको हम प्यार से ऐसे लिखते हैं OPX, and one is clinopyroxene, right. These are very very standard term, right. इसको if you are writing an exam in OPX and CPX, nobody will cut your marks, right. Like yesterday somebody submitted answer for this meteorite and he was writing about iron meteorite, right. And after writing one iron meteorite, he wrote it like this I am something something something. You can't do something like this, no. This is an informal abbreviation. You cannot write I am for iron meteorite, something like this. But this is what which is allowed, and sometimes UPSC will give ask question in such form only, right. So there are two important mineral group, right. One is pyroxene, OPX and CPX. There is also third class जो बहुत बार एग्जाम से छूट जाती है, हम भी फॉरगेट, दैट इज सोडिक pyroxene. Sodic means these are rich in sodium, alright, and what these are rich in we'll see in few minutes, right. So this is a like see here pyroxene group. Two important is orthopyroxene, clinopyroxene. This ortho comes from its orthorhombic crystal system, right, orthorhombic system. So these minerals, इसमें से दो तीन नाम होंगे important, they all have orthorhombic system. And I think recorded lecture में आएगा, right. And see this overall, right. And clinopyroxene has monoclinic crystal structure. तो ये एक सीधा important point of differentiation हो गया crystal system. One is orthorhombic, another one is monoclinic, right. And see, like just I said, OPX, CPX, and one is sodic. So this is something which you should remember. हाँ, ये वाला बहुत important है. आप मान लीजिए if you are writing exam in 2021 or 2022, चारों पेपर में आएगा, CSE में भी आएगा, IFS में भी आएगा. What about pyroxene in one form or the other? So this is something which you will be writing in exam without any doubt. So see, this is it. So this is magnesium and this is iron and, all right, this is calcium magnesium and this is calcium iron. So this end member we call, which is rich in calcium, is we call it wollastonite, but more important is this enstatite, and this is ferrosilite. इस चीज को just write in your notes. Enstatite, this one, and ferrosilite. Right. Here we have diopside. Right. This member, and here we have Heidelbergite. इतना डिफिकल्ट नहीं है जितना लग रहा है ना. जस्ट दिस इज डी ए बी सी डी ई एफ जी की जगह एच है बस. तो ए बी सी डी तो है, राइट. डी ई एफ एन एच. जस्ट रिमेंबर दिस एंड इसको बाबा रिवाइज कर लो. यू विल नो व्हाट डी स्टैंड्स फॉर. इज डाइऑक्साइड, ई फॉर एंस्टेटाइट, एफ फॉर फेरोसेलाइट एंड एच फॉर हेडेनबर्गाइट, राइट. So DEFH you need to remember, and this is wollastonite. This is a very friendly name. You will remember it. Wollastonite, calcium rich pyroxene. Actually, this is not a pyroxene. We don't find this in nature because this calcium, the size of calcium plus 2 is like too big. It does not fit in the pyroxene crystal structure. No, calcium is not able to replace magnesium and iron in this pyroxene structure. So this is not a, technically this is not a pyroxene, but we include it here because it has similar formula. You have any doubt? Okay. राइट. सो चला गया. दिस इज डी ई एफ एच, राइट. इसको याद कर लो. तो रिमेंबर दिस नेम, दिस एंड ग्रुप. सो इफ यू आर राइटिंग एंस्टेड, समटाइम्स ना दे में आस्क यू, दे में आस्क शॉर्ट नोट, स्पेशली इन IFS 8 मार्कर में दे में आस्क यू समथिंग अबाउट डाइऑक्साइड. अब यू विल बी रीडिंग सो मेनी मिनरल्स. वहाँ पे एग्जाम में इट डोंट क्लिक दैट डाइऑक्साइड इज नथिंग बट इट इज pyroxene, right? So फिर you won't be able to attempt it. But if you know this DEFH is nothing but this dioxide is from pyroxene, then you can write a lot of things. You can write about basic about pyroxene, about how it has a chain silicate structure, and then you can draw this diagram and something like this. So what I wanted to tell you this, in this diagram, this bottom, these mineral, enstatite and this ferrosilite, this series, and this in between we have hyperstein. It is very very important mineral, right? So these three mineral, see here, orthopyroxene includes these three. There are many other mineral also, but these three are very important. So the E and F thing, enstatite and ferrosilite and hyperstein, these minerals are part of orthopyroxene. Similarly जो ऊपर है ना, in the middle one, this diopside, Heidelbergite and one very important augite, right? Diopside, Heidelbergite and augite. These are clinosopyroxene mineral. All right. Wollastonite is not a pyroxene as 2 calcium positive ions don't fit in single chain structure. So this is it. So just remember them, right? Just remember before the next class, be like just memorize these three names. Now you should be thorough about this diagram and the three mineral which are under OPX, three mineral which are under CPX. All right, enstatite, hyperstein, ferrosilite, dioxide, augite, and draw this diagram. So actually, since this wollastonite is not a pyroxene, we also call it not a triangle but it is a pseudo quadrilateral. Alright, only this is what we include. This is what we include. We don't include this. So actually pyroxene has a pseudo quadrilateral. So maybe if they ask you an exam about something about pseudo, write a short note on pseudo quadrilateral of pyroxene. So you will be writing this, you will be drawing this triangle only, right? So this is what. So we know that these are OPX and these minerals are CPX. C for clino and C for calcium. So you can see that in clinopyroxene some amount of calcium is present. Now one calcium atom is there in 1 mole of this pyroxene. Similarly here there is calcium iron series, calcium magnesium. There are not 2 calcium, wollastonite is not there, but these are what. And apart from dioxide, Heidelbergite, we have augite as an important CPX. Alright, in OPX we have anstatite, ferrosilite, and we also have another important mineral, hyperstein. It is also important. So you can remember these 6 names. It is very, very important. And like initially I mentioned that there are basically 3 types of pyroxene. One is OPX, one is CPX, another one is sodic pyroxene, which are rich in sodium. So this is another solid solution series, whose important. See, you can see you don't remember maybe. If you even forget the formula of this, it's okay, but it is not difficult. We have this Si2O3 1:3 silicon oxygen ratio, and here we have sodium along with aluminium. Here we have sodium and iron, right? And here also we have sodium, right? So the very 3 most important member of this sodic pyroxene group is jadeite, agerine, and omphacite. Omphacite is a very, very important mineral when we will read about eclogite metamorphic species. It is one of the characteristic mineral in the assemblage, right? What? Omphacite. So उस समय you should not be clueless ki what is omphacite, and it should not be like you are ratifying everything. At least you should remember that omphacite is nothing but it is a sodic pyroxene. So just remember 3 names here, right? Here, what 3 names we remember of OPX, right? These 3: anstatite, hyperstein, ferrosilite. 3 names we should remember about CPX: dioxide, augite, and Heidelbergite. And in the sodic pyroxene, jadeite, agerine, and omphacite. Right? So this is it. So if you are able to draw this diagram and just mention even these 3 names, agerine, jadeite, and omphacite, you will give good marks. Alright. So this is the general property of pyroxene mineral. So alright, they are usually in this PPL, they are generally colorless. Sometimes they are grey and pale based on the chemical composition, right? If sometimes they have calcium, then they will appear, they have different color. Magnesium, they have different color. And if we have this ferrosilite, anstatite, they have different colors. So there are different various colors. The most important property of pyroxene is it has 2 very well formed set of cleavages, right? 2 set of both OPX as well as CPX, means all pyroxene, they have 2 set of cleavages. And the most striking and distinguishing feature about those set of cleavages is they intersect at 90 degree. Alright, so suppose this is a set of cleavage, fracture zone, and then there will be this is 90 degree. It might not look like 90 degree, but this is 90 degree. Alright, so they have 2 sets of cleavages which intersect at 90 degree. So it is the most important property of pyroxene. Alright, because sometimes when you will have thin section, there are 2 important minerals, pyroxenes, various pyroxenes, and amphibole. Both are present and both have 2 well developed set of cleavages. Alright, so how will you distinguish between them? By the angle between the 2 sets. So pyroxene have 90 degree angle, 89 to 90 degree angle, and this amphibole they have such angle. This angle is 56 degree and this obtuse angle is 124 degree. So they intersect at 56 and 124 degree, and in amphibole, right? And in pyroxene, the angle between cleavage is 90 degree, right? So this is the okay. So don't worry, just few more minutes of classes left, and then we'll stop and we'll start amphibole double chin silicate in the next class. So see, this is nothing but diopside, right? This is diopside. What is diopside? Whether it is CPX, OPX,
CPX.
yes, perfect, yeah, or sodic. So it is CPX because here D, this is CPX. So it is nothing but it is ultimately a pyroxene. So this is how it looks like. Now if you will focus a little bit more, you can see the two sets of cleavage. One, two. No, this is one set of cleavage, and there is an perpendicular set of cleavages are there, right? You can see this. So see, thin section में ही इतना clearly दिख रहा है कि the angle between two sets of cleavages is 90 degree. So यही distinguishing property हो जाती है इनकी. So okay, so see diagnostic property. Sometimes they ask short note on diagnostic property. Three. All pyroxene show two cleavages which intersect at 90 degree, approximately at 90 degree. In some books you might find they will say 87 and 93 degree, something like this. 90 से थोड़ा सा कम. So this is 87 and this one is 93. So you can approximate it to 90 perpendicularly है, more or less. See, you can draw this diagram in exam. Now these are two sets of cleavages. This is one set and this perpendicular is the second set of cleavages, right? So ये one important है. अब this is a very very common question in OPX and CPX. अगर आप you will see last 5 year question, यही सवाल 2 या 3 बार पूछ चुके हैं वो घुमा के. एक बार तो directly the first question in the paper was differentiate between OPX and CPX, and this was in IFS, and this was I think the year 2016 maybe or 2017. So this was a time that the people were not preparing geology, which was the second optional in good detail and in any detail. They just read Banger and they think they will clear the exam, right? So a lot of my friends also they did the same, and they went to examination and the first question was differentiate between OPX and CPX. UPSC did not even give the full form of them, and most of them have no clue what does this OPX means. So it is nothing but it is ortho and clinopyroxene. So but now from 2017 onwards, the level of competition has increased and people are like dedicating that more time for geology and now going in much more detail. But earlier times that was not the case. Like even 4 or 5 years ago, right? So this is a very common question: differentiate between OPX and CPX. So we will have a lot of fodder to write on them, but the most important distinguishing property is their extinction angle. Now OPX will show parallel extinction, alright, and CPX will show inclined extinction. So this is something which should be in your tip. Write it somewhere, revise it so many times, and just be thorough with it that this is something. OPX show parallel and this show inclined extinction. Alright. Sometimes this is also a question. ऐसा पूछ लेते हैं कि if in a thin section you are seeing two different minerals, which both have two sets of cleavages. So how will you, and one of them is amphibole, one of them is pyroxene. So how will you identify them? Alright, this is a very common question in practical laboratory in geology courses in any university, right? So this is very simple. Pyroxene, we know that the cleavage angle is 90 degree. In amphibole the cleavage angle is like 56 degree, 56 and 124 degree, right? So this is how you can directly differentiate between amphibole and pyroxene. But then there are various kind of pyroxene. They will ask you which pyroxene is it? Is it CPX or OPX? Then we know that one thing we know that we can differentiate them based on their extinction angle under cross polar, right? So if we have parallel extinction, we will have OPX. If there is inclined extinction, we will have CPX. And even sodium pyroxene. Alright, what are name few sodium pyroxene?
Jadeite.
Yes, and
uh,
एजेरीन.
Agerine.
एंड वन वेरी वेरी इंपॉर्टेंट वन जो इक्लोजाइट फेसिस में मिलती है इन मेटामॉर्फिक,
Eclosaid.
ओम्फासाइट, राइट.
First.
हाँ, डोंट वरी, यू आप ऐसे दो चार बार आप पढ़ोगे, इट विल बी वेरी कंफर्टेबल. एंड व्हेन यू विल बी डन विद मेटामॉर्फिक पेट्रोलॉजी ना, तो दिस विल बी ना वेरी वेरी लाइक these will be your buddies, ओम्फासाइट एंड CPX, OPX. You will use them so many times and you will remember them, right? So what here if they show parallel extinction, we will say they are OPX. If they show inclined extinction, they are either CPX or SODIC. So इतना ही पूछते हैं एग्जाम में जनरली, बट आई हैव स्टिल इंक्लूडेड देम इन माई नोट्स दैट इन इफ इट इज ऑगाइट ना, देर आर ऑल्सो वेरियस टाइप्स ऑफ CPX. So if it is augite is a famous mineral, so it has high relief second order interference color and 2V angle is 40 to 70. All right, so this is something you can write in your notes. एक दो बार रिवाइज कर लेना, फैक्चुअल सी चीज़ है. हाँ, this part I'll clear it up and I'll also share the PDF. All right, and then एक थ्योरेटिकल डिफरेंस तो हमें पता है. जो प्रैक्टिकल डिफरेंस है इन OPX एंड CPX, इट इज एक्सटिंक्शन से रिलेटेड है. All right, एक OPX is parallel, CPX is inclined extinction, and the नाम से ही आता है orthorhombic is OPX is orthorhombic, CPX is monoclinic. All right, so both are biaxial, but they also have a difference in their crystal system. So if you are able to write these 2 points only na in exam, if they are asking about OPX versus CPX, तो प्रैक्टिकली तो एक ही पॉइंट है, एक्सटिंक्शन एंगल, सबसे मेजर इंपॉर्टेंट पॉइंट ना. बट ना यू स्टार्ट देम, बोथ आर पार्ट ऑफ पायरोक्सिन ग्रुप ऑफ मिनरल, दोनों का चेन सिलिकेट स्ट्रक्चर है. एंड द मोस्ट इंपॉर्टेंट पॉइंट इज वो ट्राइंगल डायग्राम बना दो. इफ आर एबल टू ड्रॉ दिस ट्राइंगल डायग्राम, यू आर ऑलरेडी अहेड ऑफ 90-95% पीपल, है ना. एंड दिस शोज लाइक दिस, these group of minerals are CPX, these group of minerals are OPX, राइट. नाम हो गया एंस्टेटाइट, फेरोसेलाइट एंड हाइपरस्टीन. ऑलराइट, इसमें नाम इज डाइऑक्साइड, ऑगाइट एंड हेडेनबर्गाइट, राइट. ये हो गया. देन उसके बाद दे हैव अ डिफरेंट क्रिस्टल सिस्टम. O for orthopyroxene, O for orthorhombic है, and it has monoclinic, right. And the third is their extinction. So it will be a good 8 marker में you will have this. And these are two other important dimension of pyroxene. One is phase diagram and one is occurrence. Occurrence, like again we discussed, is nothing where in which rocks, in association with which rock do you find pyroxene. So obviously pyroxene is an ultramafic rock, so you will find them with ultramafic minerals, you will find with ultramafic rock and something like this. So don't worry about it, we will cover it, yeah, in after petrology, when you will be done with your igneous and metamorphic, then these two will be nothing but a cakewalk. So you can leave a half page for them. One is for phase diagram between enstatite and ferrosilite and diopside and Heidelbergite. So when you will be reading this phase diagram between diopside and Heidelbergite, this is actually directly mentioned in our syllabus, petrology syllabus. So it is nothing but we are reading about the phase diagram of CPX, and here about OPX के दो मिनरल के बीच में phase diagram हम पढ़ रहे हैं solid solution series के. So it is nothing, very easy thing which we will cover after petrology. So I think this is more than sufficient for pyroxene, and you will be able to cover all the question with this. So now what you should do this now after class, you should revise them whatever the mineral we have covered today, and then you should also go to the website on the portal where we have uploaded these videos. So just go through them, like this is pyroxene which we have uploaded. So I hope it is visible. So this is nothing but in this notes composition, these are the mineral group. ये नीचे उनका this is the diagram, ternary diagram, we have drawn this. Then physical properties we have covered, so just go through them. They have two cleavages, the hardness you can 5 to 6 only, and then other sign, this is what we covered. So this is a very structured notes, already almost producible in exam. So इसमें there are more information which we covered in class. So if you want, you can add them, but at least write whatever we discussed in class in the exam, right? Then this is the structure of individual, I think, CPX, then additional information about This is nothing but sodic pyroxene, agerine, jadeite and omphacite, right? And then something about this, and then we have some specific write up on clinopyroxene, the same physical property, the monoclinic crystal system, right? And the cleavages and all these things. So revise these notes also, and I will also upload the PPT, right? So if you have any doubt, you can ask. Otherwise, we will continue from amphibole and the last 3 silicate structure day after tomorrow, right? So do you have any doubt from today's session or anything? Alright, so I think we'll end the class, and if you have any doubt, you can always ask on the Telegram group, or you can send us a mail, right? So see you day after tomorrow, or I'll tell you the time in the evening. Alright, take care
Thank you, sir.
and revise whatever we did today.